Good morning, guys. How are you? I hope that you had a good night's sleep. So we're going to start chapter 2 today. And remember that Friday is your test. Hybrid B, if you don't like what test, we're going to talk about it tomorrow, but there is a test on Friday. But I wanted to start chapter 2 just so that we're not getting too far behind. And so we're going to take our notes today. And what we're going to talk about is relations and functions. So we're going into our linear unit, linear lines, okay? So we are going to have some vocabulary, and I'm going to ask you to define it. I'm going to put the vocabulary list up there. So there's a couple things that you need to know. So the first one is, let's look at the first 3 key concepts here. So that vocabulary, we're going to talk a little bit about it today, but right in our notes, but we're going to talk about this. So a one-to-one function, okay, so these are one-to-one function, onto function, and both onto and one-to-one. Notice that each element of the domain pairs to exactly one unique element of the range. So 1 goes to D, 2 goes to B, 3 goes to A. There's one element that's not out there, but at least the domain goes to exactly one of the ranges. And the domain is always your X value. So this is usually your X value. This is usually your Y value. This is your X value. This is your F of X. This is what we call F of X. Okay, and the reason I'm showing you that is because later we're going to talk about X and Y and X and F of X. So notice that the onto function, each element of the range corresponds to an element of the domain. But notice this time that 3 goes to C and 4 goes to C. So this one is they're all relations, okay? They're all relations, but this one is not a function. It's not a function because the domain, it doesn't have an exact match. Okay, so I paused it for the bell. Okay, so this is a function, but this is not, because if you read right here, it says, recall that a function is a relation in which each element of the domain is paired with exactly one element in the range. Okay, so what we're going to do now is we're going to look at 3 examples, 1, 2, and 3. And we're going to decide if it's a function, if it's and then if it is a function, determine if it's one-to-one, onto, both, or neither. Okay, so here we go with this. So you guys, the first thing that we're going to do is we're going to list the domain for number 1. To list the domain, we're going to put D, and I usually put equals, and then I put those little bracket things that you guys want to practice so much. And we're going to list our X's, okay? Now, there's a couple things that you can do. Remember, if an X repeats, you don't write it. You only write it once. So we're going to start over here. We're going to start with our least. So this is 1, 2, 3. So we have a -3. Oh, we have 2 -2s. -2, -2. We have a -1. So you guys, I'm just going, so this, I went 1, 2, 3, so that's a -3, that's a -2, that's a -1, that's a 0. Then we have a 1. Remember, this is the X. Over here we have 1, 2, 3, so we have a 3. And then it looks like we have a 4. Okay. So those are my X values. You guys, again, I only wrote 1, -2 because I don't need to write it more than once. Then I have a range, and now my range is my Y values. Okay, so we're gonna do the same thing. So this is our Y. We're gonna start down here because we always start with our least amount. So it's 1, 2, 3, 4, 3. So we have a -3. It looks like we have a -2. We have no zeros. We have a 1. We have a 2. And 1, 2, 3, 4. And that's our range. Okay. Now, you guys, if you're not sure, you're like, Miss Fleur, you just confused me. I just want to show you. So this ordered pair is 1, 2, 3. So this ordered pair was -3, 2. -3 goes in the domain, 2 goes in the range. This one was -2, 1, and -2, -2. So -2 went to the domain, 1 went to the range, -2 went to the range. So it's just the ordered pair. So the X's are your domains, the Y's are your ranges. Now, you guys, I have more domains than ranges because remember that your domain cannot repeat. Basically, your domain can't repeat. So this is not a function. And since it's not a function, it can't be, it's not going to be any of these, okay? So let's do this one. So our domain is going to be, I know I smashed it in, I didn't mean to. So we're going to write -3, -2, -1, 0, 1. And then our range is 0, 2, 4, 6, and it's 8. Now, do you see how the 1 goes to the 6 and the -1 goes to the 6? Yeah, I paused it. Yep. Okay. So, you guys, this is a function. Even though 8 doesn't have one, it all goes straight. Like each domain has exactly one range. So this is what we call a function. And it is not 1-to-1, and it's not onto. Okay? Because of this 8. Okay, so now number 3. Our domain is -2, 1, 4, 8. Our range is -4, -2, and 6. So again, you guys, the range can repeat, the domain can't repeat. That's why on the first one, it's not a function because the domain repeated a number. But in this one, the domain does not repeat. So that's why this one is a function. Now we have to determine if it's onto or into. Okay, in this particular one, would be, well, it's definitely onto. So we're going to say it's both of them. It's both. Yeah, we'll go with that. You guys, if you don't understand the onto function, we'll be fine. The big thing here is that you know the domain and the range. Okay? Okay. Let's see, how much time have I used? So, only 8 minutes. Look at that, you guys. So, again, it's not a function if the domain repeats. The domain can't repeat. The range can repeat, but the domain can't repeat. Okay. Now, we're going to flip it over, and hopefully I can get this in. So, to determine if something is a function or not, you can use the vertical line test. You guys, an open parabola, that's what this is, or quadratic. See how this line, this is the vertical line, see how it goes through and it only hits the parabola in one spot? Like, you can draw many lines and it's never going to hit in one spot. So this is what we call a function. This one, if we use the vertical line test, see how it hits here and here? This is not a function because that vertical line hits the graph in two places. The vertical line can only hit the graph in one place. You guys, a lot of people say, well, that hits it in more. Nope, it's only hitting at one place. It only intersects the graph in one place. This vertical line intersects the graph into two places. Now, we're going to talk about, oh, can you see that? It's not a function. We're going to talk about a discrete relation. A discrete relation is when you have points not connected. And a continuous relation is a line or smooth curve. And that means that your dots are connected. Oh, you can't see that, sorry. Okay, so a discrete relation is points not connected. A continuous relation is a line or smooth curve. Again, you guys, this is a function because the vertical line only intersects the graph in one spot. This is not a function because the vertical line that you're drawing will hit the graph or intersect the graph into 2 points. And then we'll go back and we'll just touch on into the functions on the front. But the functions, remember, it's a function as long as the domain does not repeat. So what we're going to do now is we are going to do this equation, this problem right here. The number of employees a company had in each year from 2004 to 2009 were 25, 28, 34, 31, 27, and 29. We're going to graph this information and to determine whether the relation is discrete or continuous. Does the graph represent a function? So, you guys ready? I am. Yay, yay, yay. So on the bottom, we're going to write, I'm going to move my chart so I can do this. So it starts at 2004, goes to 2009.